Okay, this is 2009, it's the first DCG exam, and looking at the intersection of solids question here. The setup of the question is fairly straightforward. So it's based on a square-based prism, which is upright. You're given the plan view of it. This is all scaled 1 to 10, by the way. You're given the plan view of it. It's inclined at 60 degrees. It's square, so obviously the length and breadth are the same. And you're given the heights of it and the elevation here, so no real problem setting that up. Passing through it at an angle of 30 degrees is a square prism, and again it's inclined at 85 degrees up here in elevation in the profile of it, and the width again is the same as the length because it's square based. So in setting up the question, I've done that already just to save time in the video, and didn't really encounter any problems, so there shouldn't be an issue there. The one thing I will talk you through is finding these lines here down in plan view. So they're the lines belonging to the 30 degree square which is passing through the first object. You're given one of them. You're given the furthest point, which is back here, and you can see that in the question. They give you an indication of where that line starts. You're not given a distance down for any of the rest of them. So what you have to do is create this profile first of all, which I've done in my drawing up here. That's the one that's inclined at 85 degrees. And I've labelled all 4 corners with numbers. Now it doesn't make any difference what order you number them in, but just make sure they have numbers. Then what I would do is look at the drawing itself given in the question. You can see that one of the lines is broken. That means it's hidden, and the other 3 are visible from the elevation. They're finished lines. So that means that line that's broken must be the line that's furthest back, because the others are overshadowing, they're hiding it. Which means that it must be this line here, because that's the furthest line back in the plan view. That means it's at the back of my view in elevation. So what I'm going to do is I'm going to use that as a start point. Now if I was to look down on top of that profile where I'm drawing the arrowhead now, it will give me a plan view of it. And this point here is at the back of my drawing. So what I'm going to do is I'm going to measure the distance from here to the next point, to the next point, and then finally to the last point. And I'm going to measure that perpendicularly. So therefore I'm looking straight down it in a plan view. So if I take the distance, let's say from corner 1 to corner 2, I can then take that distance and it's going to be the same in plan view. And you just repeat that for the other 2 points. And you can see that's what I've done in my drawing. I've taken the distance between 1 and 2, the distance between 2 and 3, and the distance between 3 and 4, and I've just replicated it down in the plan view here. So that's as much as I can do for now. After that, I'm going to have to actually try and complete the drawing by showing where both objects pass through each other and finding the points of contact, the points of intersection. So the easiest way of doing that is to draw an auxiliary view of your objects. You're going to look down at whatever angle your second object is inclined at, 30 degrees in this case. So I'm looking down at 30 degrees for an auxiliary view. So I've set up my x1, y1 line, as you can see here. Just label that. And you can try and do too much at the one time with this question. That's what makes it complex. So if you just take it one shape at a time, it's the easiest method. So what I would do is bring down the shape that 30 degrees, bring it down first of all, the 4 corners of it. In terms of the distances you're going to use, you're measuring back 2 views all the time, same with every auxiliary view you make. So measuring back 2 views, if I'm here, one view will bring me back to the elevation, the second view will bring me back down to the plan view. So I'll be measuring from my XY line down to line 1, as I've called it, following line 1 and making the mark there. Same for line 2, line 3, line 4, and marking them off. So the first shape I would have drawn down here would have been that square. So I'm looking straight down on top of it. Just repeat that process for the prism which is standing upright. So bring it down next. Find all of the points. So you're measuring down as far as all of these corners, as you can see, and of course the apex of the roof. And you're marking them all down on the lines that they belong to. What that gives you is a 3D view of one object clearly passing through the other. Now, this is where the work starts with this question. So this view here, and we're going to go through how to mark off the intersections between them. The object's going to enter in on the front side of it here, and then obviously it has to pass out on the other side as well. So what we're going to do is we're going to mark off where does it enter the object first of all, and we're just going to focus on that. And once we have that done, we can then go back and focus on where does it exit. So I have the 4 corners labelled 1, 2, 3 and 4. I have that previously done from my elevation. Wherever it crosses over a corner, for instance here, 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 they're quite easy to mark off. So we can just make those points right now. And what we'll do is we'll label them. So if I have numbers going the whole way around, I'm going to continue that method. So I'll start off with number 1, corner 1. I'll go back down and it's going to hit this corner here. Okay, so I've counted up as far as 4, so I'll call that 5. From 5 goes to 3, 3 goes to 4, 4 goes back up to 2, but along the way it crosses over that corner. So we'll call that point 6. Goes back up to 2, and it's going to make its way back down towards corner 1 to go full circle, but on the way it's going to cross over 2 corners, this one here and this one here. So I'm going to call that 7 and 8. Okay, so they're all called numbers. They don't go in order, but we'll go with that for now. A good tip as well would be just to write them out so you can keep track of that and put them in the correct order. So starting off with 1 and going clockwise, we go to 5. We then go to 3, 4, 6, 2, 7, 8, and then all the way back to 1. Okay, so that's the entry. We're going to bring those back up to our elevation. Now, once again, any of the ones that are on corners are quite easy to find back up here in elevation because they're along lines that we already have. For instance, corner 8 here, it's along the line B to C, which I've already labelled. So when I bring that back up at 30 degrees, I know that when I bring it up, it's going to cross over the line BC, and that's going to find point 8 for me. So that would be point 8. Point 5 is also on a corner. It's the one on the one that I've called CC. So when I bring up point 5 and it crosses over the line CC, I can mark off point 5 in its exact location. And just repeat that for the other ones that I know that are on corners. So point 6 is on the line from D to C. Point 7 is on one of the lines on the roof. And then I'm back down to point 8 again. The ones that require a little bit of work are the points that are passing through a flat surface, so they're not on corners. So they would be number 1, number 3, number 4, and number 2. The reason they require a little bit more work is because we don't have anything for them to cross over when we bring them back up, so we don't know where to stop them. So for instance, if we bring point 1 up, you have no idea where it stops. So what we do is we create a reference line. This is the method I use anyway. So I'm going to concentrate on point 1 and I'm going to talk you through it, and then I'll just do the rest of them automatically, presuming you know what you're doing. Corner 1 is crashing into this flat surface. That flat surface in my drawing is from C to B, back down to B on the ground, over to C on the ground, and back up. So that flat surface, corner 1 is crashing into it. So what I'm going to do is I'm going to create a reference line, and the way I'm going to do that is to pick any of the 4 corners. So I'll pick B, pass it through corner 1, and pass it through it until it gets to the other side of the surface that I'm talking about, and then stop it at that stage. That's a reference line. So wherever it hits the side of the surface on the other, on the left hand side, I'm going to call a reference point. I can find that reference point up in my elevation. It's on the line from C to C. So I bring that up and I make a note of my reference point. And my reference point was joined from B originally, so I'm going to redraw that. Now, what that does is it creates a crossover for where I'm bringing point 1 up. So where the two of them cross over each other is where corner 1 hits into that surface. And I can label it. So then we just repeat that for the other 3. So I create reference lines for corner 4, and you can create them from any corner, it doesn't matter, as long as it goes from one side of the surface through the point and out onto the other side of the surface. This one here is on the roof, so I'll join from E down through corner 2 until it hits the other end of that surface. Join it back to E, and then see where corner 2 crosses over that reference. Okay, that's all of them done. So now in my elevation I actually have all the points that I need. I just need to make sense of it at this stage. What am I going to see? How are they going to join together? What's going to be hidden? A good way of thinking of it is to know what's hidden and what's visible when you're seeing the intersection. Look back up in this direction. So where I'm drawing the arrowhead. So everything on the left hand side here I'm going to see, and everything on the right hand side is going to be hidden by the front of the object. So that means I'll see all of these lines here joining to each other, and the ones at the back will be hidden. And again, you can write that down if you want to, or you can just keep referencing down as you're drawing them together. Okay, so I'm going to start at the very top. I'm going to go to corner 2 first of all. Now, just concentrating on what I'm seeing. Corner 2 will go to 6, and that'll be visible. 6 will go to 4, so I'm kind of tracking this backwards. So 6 to 4 is visible. 4 goes down to 3. So corner 3. I actually didn't have the reference done for that, so I'll just finish that off really quickly. Okay, so that's 3. So I'll see from 4 to 3. Okay, and then any of the rest of them from this side over are going to be hidden. So 3 is going to go up to 5, but that'll be a broken line. 5 goes back to 1. 1 goes up to 8. And 8 goes to 7, and then 7 goes back to 2. And they're all hidden lines. Okay, so kind of what I have up here. I have corner 2 coming in as far as there. I have corner 4 coming in as far as there. And I have corner 3 coming in as far as there. Everything else is hidden behind them. Corner 1, which is at the back, is hidden, and they told you that in the setup of the question. You could see that. Okay, so you can see that's now completed. Now we go back down to our auxiliary view, and what we're now going to try and concentrate on is the exit points. So this is what can cause a little bit of difficulty sometimes. So you have to try and visualize what does the back of this object look like. So the back surface is going along here, and down, back along the floor, and back up. Okay, it's hidden, but we try and look through it. So what we're now looking for is the same thing, except we're looking for corners, and where it goes through a flat surface. Again, they're going to be different. So we start off with corner 1, and we're looking at the exit points at this stage. So the exit here for corner 1 is actually exactly on the corner there, so that's quite convenient. That goes down to corner 3 unobstructed. and corner 3 just crashes into the ground. So again, that's fine. Corner 3 goes back and hits that broken line, so that's all along the ground, so that's easy. Corner 4, again passing through a flat surface, and then back up to corner 2. Okay, so we're going to have to get reference lines for 2 and 4. The rest of them are either on the ground or on exact corners. So I'll draw my reference for corner 2. Okay, so that's it there. And then I'll draw my reference for corner 4. Alright. Now again, I'm looking in from this side. So I'm going to see 2 to 4. I'm going to see 4 hitting the ground, and then everything else is going to be hidden. Four hits the ground there. Okay, 4 goes to 3, which is hitting the ground, so that's just a flat line. 3 goes back to 1. Number 1 is there. Again on the ground, hidden. And 1 goes back up to 2. And again, that's hidden. So now I can look at my elevation, and I can draw line 2 going out as far as where it stops. I can draw line 4 going down as far as the ground. Everything else is hidden. Put my XY line heavy and just tidy it up there at the edge. Right, so that's basically the intersection. What I can do now is go heavy over the original shape, what's left of it, and it should be a little bit clearer then what this looks like. What helps sometimes, if you can shade in one of the shapes, it just helps it to stand out in perhaps a light kind of a pastel colour, just to show it up against the other one. If you are shading in anything, just be careful not to overpower any construction lines that you would have used, because otherwise the examiner won't be able to make them out. That's the elevation complete. Now the plan view doesn't take half as long because we have most of the work done. So all we have to do now in plan view is just drop points down and reference them off what we already have. Again, concentrate on just the entry points first of all, and then concentrate on the exit points. Otherwise you get mixed up between them. So I'm going to drop down all the points and try and find out where they are in plan view. We'll do these in order. So line 1 came in as far as that point there. So if I drop it down into plan view, you'll see it's just hitting against the edge. So that's fine. That's where it stops. Corner 2 comes in as far as there and stops. 3 and 4 exactly the same. Okay, and then find the extra points that we got. So we have 0.5 is on the very corner. So again, that's fine. 0.6 is along a line from D to C. 7 is along one of the roof lines, goes from E to C. And 8 is along the line CB. Okay. And again, to help you realise what's visible and what's hidden, just go back to your auxiliary view and imagine you're looking straight down on top of it. So you will see everything above the pen, you're going to see that as heavy lines, and then everything below it is going to appear as a hidden line because it'll be overshadowed. So we'll try and join them up in that order then. So going from 4 to 6, let's see that. 6 up to 2. 2 to 7. 7 to 8, and then the rest of them, completing the circuit, will be hidden. So 8 goes to 1 along the edge, 1 goes back down to 5, which will be hidden, 5 goes to 3, and then 3 goes back to 4, and they're hidden. Then you can draw your lines in as far as where they stop. So corner 1 goes in as far as there, corner 2, 3 is going to be hidden, and 4. Okay. You have got a little flat cut here to contend with, so just don't forget about that. So that's along the corner 2 line. Okay, so that shouldn't have actually gone heavy. Okay, so that's what your plan view will look like. And again, they give you a kind of a half preview of that, so you know what it looks like. And then the exit points, as you can see in the plan view, are all just along that edge. Okay, so there's no real work in finishing that off. Now, it's a long question, but if you can just get into the habit of doing them, they're very, very repetitive. Okay, and in terms of knowing where to find these points here, you're going to be going back down to your auxiliary and you're looking for where they hit the ground. So I'm noting that measurement there and marking it down in plan view. And likewise the same measurement here. So, if I was to summarise, the main areas to work on are drawing the profile here at the very beginning and then finding those points off that. So you're taking those measurements and transferring them down. That's a common kind of a problem they put in it, so just get used to doing that. And then down in the auxiliary, the main issue with lads have is with reference points. So maybe just look back over that particular area of the question or the video. And look over it a few times, just see how I was doing that. But once you get the hang of it, you get quite quick at it then.